Hello everyone, welcome to the session on time series. I am Mrs. Khedikar, working as an assistant professor in Computer Science and Engineering Department at Walchand Institute of Technology, Solapur. Let's start with the learning outcome. At the end of this session, student will be able to describe the time series and the components of time series. These are the contents of this session. So here we are going to see the definition of time series with example, then the time series analysis, components of time series. Let's start with the definition of time series. So here time series is a sequence of numerical data points in successive order. That means here the time series track the movement of the chosen data point. For example, the security price over a specified period of time with the data points recorded at regular interval. So that regular interval may be an hour, maybe a week, maybe a month. So we can say that the time series data are a collection of ordered observations recorded at a specific time, for instance hours, month or years. Now let me explain you this with the help of this example. So here I have taken the bio-monthly electricity consumption. So in this example, time series are commonly used to predict the consumption in the utility industries. The time series shown the consumption of the electricity in an Italian region expressed in the tens of millions of kilowatt hours, which is recorded every 2 months from the first 2 month period of 1998 to the 6th 2 month period of 2003. Look at this graph. Here on x-axis, this graph shows the time, that means year, which starts from 1998 to 2004, and on this opposite axis it shows the electricity consumptions. Electricity consumption in thousands of kilowatt, right? So here in a year it just takes the electricity consumption record in a 6 time, okay, means yearly it takes 6 time. So after every 2 years it takes the electricity consumption. So here are total 36 2 month period. That means this graph shows the time series of electricity consumption in an Italian region over the 36 2 month period. And from this graph we can identify one pattern. And what is that pattern? Here at the starting of the year the electric consumption is low, whereas at the end of the year the electricity consumption is high, whereas at the last month of this year it is again come low. So this pattern is obtained after, in every year. So in this way we can identify the pattern. Now let's see the time series analysis. It can be useful to see how a given asset, security or an economic variable changes over a time. Time series analysis examine how the changes associated with the chosen data point compared to shift in other variables over the same period of time. So how it works? So let me explain you this example. Suppose we want to analyze the time series of a daily closing stock prices for a given stock over a period of 1 year. So you would obtain a list of all the closing prices for the stock from each day for the past year, and then we list them in a chronological order, right? So this would be a 1 year daily closing price time series for the stock, and from this sheet only we can identify the pattern. So this is time series analysis. Now so in this stock market, whenever we just identify the daily closing price, so here the values taken by the variable over a time, and then time is measured in, maybe that is a daily sales revenue, maybe that is a weekly orders, monthly overhead, yearly income, whatever it is. So it is in a period. So that recorded stock prices are tabulated or plotted as a chronological order, or the numbers or a data points. Okay. So to get the valid statistical inferences, the values must be repeatedly measured, often over the 4 to 5 years period, and then only we get the stable pattern. Now let us see where do we use this time series analysis. That means the application of time series analysis in various areas. So time series analysis is used in the budget analysis, in the financial market analysis, census analysis, inventory management, economic forecasting, marketing and sales forecasting, yield projection, seismological predictions, workload projections, military planning, and in many areas. Now let us see the goal of time series analysis. So there are two main goals of time series analysis. First, to identify the nature of the phenomena represented by the sequence of the observation in the data, and the second, to use the data to forecast or predict the future value of the time series variable. So both these goals are used to identify the pattern of the observed time series data, and once you identify the pattern, we can interpret and integrate it with the other data. That means we can use the same pattern for the prediction for other data also. So this is about the time series and the time series analysis. Now please pause the video for a while and answer this question. Which of the following is an example of time series problem? The first example is estimation number of hotel rooms booking in next 6 months. Estimating the total sales in next 3 years of an insurance company. Estimating the number of calls for the next 1 week. Options are only 3, 1 and 2, 2 and 3, or all. That means 1, 2 and 3. And the answer is all 3, 1, 2 and 3. Why? Because all the above options have a time component associated. Why? Because here we are checking it for the next 6 months, then for the next 3 years, then for the next 1 week. Now let us move toward the next topic, that is component of time series. So there are 4 components of time series. The first one is trend, represented as capital T, then the cyclical, seasonal and irregular. So these components may be combined in a different ways. It is usually assumed that they are multiplied or added. So for the multiplication and for the addition, we have given here the expression that y t equal to t multiplied by c multiplied by s multiplied by I. Similarly for addition. So let us see the first component of time series, that is trend. The trend is the long term pattern of the time series. A trend can be positive or negative depending on whether the time series exhibit an increasing long term pattern or the decreasing long term pattern. If the time series does not show an increasing or decreasing pattern, then the series is stationary in the mean. Now various type of trend like non-seasonal trend, additive trend and multiplicative trend combine with linear damped polynomial or exponential trend. So in the previous slide only I told you we can use all these trend combinedly. The next trend or the next component of the time series, that is cyclical. Any pattern showing an up and the down movement around a given trend is identified as a cyclical pattern. So the duration of the cycle depends on the type of business or the industry being analyzed. Cycle has often been described as a non-fixed pattern, usually of at least 2 years in duration. The length of the cycle is described as a period, and that period should be more than 2 years. Now let us see the next component of time series. The seasonality occurs when the time series exhibits the regular functions during the same month or months every year, or during the same quarter every year. For example, retail sales peak during the month of the December, or the another example, vacation packages sell more in the summer when the school is not in session. That means there are the holiday. The third example, decreases in the employment in sugar factory during the off season. So these are the examples which comes under the seasonal component of time series. Now look at the irregular component. This component is unpredictable. Every time series has some unpredictable component that make it a random variable. In prediction, the objective is to model all the components to the point that the only component remain unexplained in the random component. It results from short term fluctuation in the series which are not systematic and same instant not predictable. Now look at here the components of time series in figure. So this first figure shows the long term trend. Okay. So here the x value is also increasing and the y value is also increasing. Now look at the other figure. Here it shows the long term and the cyclical fluctuations, okay, or the movements or the variations. Now in the third figure it shows the long term as well as cyclical as well as seasonal. Then in the next figure it shows all four components of time series. That is, it shows the long term by using this arrow, then there is a cyclical, then there is a seasonal, and also there is a irregular pattern also. Now in the next diagram, here it shows the combination of the component of time series. So look at here, the long term trend is shown as a straight line, then the cyclical trend is shown by a curve, then the seasonal curve is shown like this fluctuated line, and the irregular fluctuations are also shown. So this is the time series analysis and time series components which are used to analyze the pattern or used to identify the patterns which are used for the future predictions. These are the references I have used for this PPT. Thank you.